Hello, today we are starting our notes over our last parent function we're going to cover this year, which is our log functions. So a log function is an inverse of an exponential function. So we can graph this by reflecting our exponential function over that line y equals x, or in other words, we are switching our x and y values. So let's first refresh our memory on our 2 to the x power exponential function. So if on y equals, I do my 2 to the x power, and then I go to my table. Let's think about some values we want here. Let's start with 0 is a good one. So that's 0, 1. 1, 2 is another one. 2, 4. 3, 8. Okay, so those are all points on my exponential function. So I'm going to go ahead and plot these, as many as will fit on my graph. And if we recall, this is our parent exponential function. Let's go ahead and fill in these characteristics here. My domain is all real numbers. My range is all positive values. I have a y-intercept at 0, 1. My function is increasing. And I have a horizontal asymptote at y equals 0. Okay. Now let's go on to our log function. My log is going to be the inverse of this exponential function, so I'm just going to swap the x's and the y's. So this is going to be 1, 0, 2, 1, 4, 2, 8, 3, and so on. So I'm going to go ahead and plot as many of those as will fit on my graph. And just for the sake of seeing what this looks like on the graph, in my calculator, let's go ahead and type in log base 2 of x. So if I hit my math button and scroll down to alpha A, where it says log base, this will pull up the log. My base here is 2, so I'm going to put the 2 there, x, and then graph. So if you'll notice, my graph looks like this. It has the same shape as my exponential, but it's been reflected. And what it's doing is it's getting really close to the y-axis, but never quite crossing it. So I'm going to connect these dots and make sure I'm showing that feature. Okay, let's compare now these characteristics. For my log function, my domain, right, it's never crossing the y-axis, so my domain is all positive values. My range is now all real numbers. I have an x-intercept at 1, 0. My function is still increasing. If I'm walking from left to right, I'm going uphill. And now I have a vertical asymptote at x equals 0. So what has changed between these two? My domain and range kind of flip-flopped, which makes sense because my x and y values traded places. I now have an x-intercept instead of a y-intercept, and I have a vertical asymptote instead of a horizontal asymptote. So this is an intro into the graphs of our logs. Let's now practice evaluating some log functions. So you're going to need your calculator for this. For the first one, I'm doing log base 2 again, which I still have in my y equals from when we looked at the graph. If I'm telling it what inputs I want, I need to make sure that my table is set for the independent to be on ask. So now I'm going to go to my table, and I'm going to type in 1, 2, and 16. And I get as an output 0, 1, and 4. These are all positive outputs, and my inputs, well, other than 0, and my inputs were all positive values, these two being bigger than 1, and I got positive answers. Let's see how that changes with I cannot get my buttons today. Okay, let's go to number 2. I'm now doing log base 3, so I'm going to switch that 2 to a 3. And I'm going to go back to my table, and I'm going to enter 1, 3, and 1/9. And now I have 0 again, 1, and -2. So again, for 1, my output was 0. For 3, I got a positive value, but then 1/9 gave me negative. So noticing the difference here, this was a value greater than 1, and this was a value less than 1. That caused me to go from a positive to a negative output. And now let's go on to the third one, log x. I don't have a base here. So think in your head, what do you think that base is going to be? If there's no base written, what can we assume that base is? When there's no base written, we're assuming that the base is 10. So you have two options here. When your y equals menu, you can change this 3 to be a 10, or you can use your log button that's on the home page of your calculator. Right here, this log button is log 10. So I'm going to change this to be log of x. And now in my table, I'm going to do 1, 10, and 0.001. What kind of output do you think we're going to get for this? If you guessed negative, you are correct. So again, when I went from a number bigger than 1 to a number less than 1 for my input, my output became negative. Alrighty. On to the back side, we are going to do something similar to what we did with our exponential notes. We are going to look at our parent function, analyze the characteristics, and then we're going to compare how that changes with our different transformations. So we're going to look at domain range, increasing, decreasing. We're going to have x-intercepts, not y-intercepts, and we are going to have vertical asymptotes, not horizontal asymptotes. So starting with 1, log base 2 of x, this is the same function that we graphed here, so I am going to plot those points, 1, 0, 2, 1, 4, 2, getting close but not crossing the y-axis, and I'm going to start filling in my characteristics. So this is my parent function, so I don't have any transformations just yet. My domain is positive numbers. My range is all real numbers. I am increasing. My x-intercept is at 1, 0, and I have a vertical asymptote at x equals 0. This is all stuff we established on the front page. Now if I move on to number 2, this minus 3 on the outside indicates that I'm going to be shifting down 3. So I'm going to take all of those points I have on my initial function and just move them down 3 spots. And I'm going to connect the dots. And let's look at what changed and what stayed the same. So as far as my domain goes, it's still all positive numbers. My range is still all real numbers. I'm still increasing. But my x-intercept is no longer at 1, 0, and in fact, I can't even see it on my graph. So what can I do to figure that out? Well, your x-intercept is when y equals 0, so it's when this is equal to 0. But we don't know how to solve log equations yet, so how can I figure this out? I'm going to go to my calculator, and I'm going to put in my log transformed function, log base 2 of x minus 3 on the outside. And what it's doing is it's crossing my x-axis, which is also the equation of the line y equals 0. So if I plot both of those on my graph, and I'm going to use my graph to tell me where those two lines overlap, where they intersect. It's somewhere over here. So I am going to use the buttons second, calc, and scroll down to option 5, which is intersect. And I'm going to arrow over as close as I can to where that intersection is. And I'm going to hit the enter button 3 times. 1, 2, 3. And it will tell me my intersection is at 8, 0. So when y is 0, x is 8. So that is my x-intercept. And if you need to see those steps in the calculator again, you can just rewind. So there is my new x-intercept. And I didn't shift to the left or to the right, so my vertical asymptote is the same, still x equals 0. Okay, let's go on to these next two transformations. On 3, I am reflecting over the x-axis. So I'm going to take my points from my initial function and reflect them across my x-axis. And my function is going to kind of be turned upside down. So this is my new transformed function. My domain is still all positive numbers. My range is still all real numbers. I am now decreasing. If I'm walking from left to right, I'm going downhill. My x-intercept did not change, and neither did my vertical asymptote. Okay, last but not least, I have two transformations happening here. We are going to be going to the left 2 and up 3. So I'm going to take each of those points from my parent function and go left 2 and up 3. So here is my transformed function. The shape of it did not change. And let's talk about what is the same and what is different. My domain, my x values. I have now shifted 2 units to the left, which means my x values have shifted 2 units to the left. So my domain is now from -2 to positive infinity. My range is still all real numbers. My function is increasing still. My x-intercept, however, has moved. So I need to find that new x-intercept. I'm going to do this in the calculator again. I'm going to put in my new function, log base 2 of x plus 2 plus 3. And I'm still going to have that y equals 0. And now I'm going to graph that. And I'm going to use that intersect function again to find where they overlap. So second calc, intersect. Arrow over as close as you can, enter, 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 and when y is 0, x is -1.875. So there's my new x-intercept. Again, we eventually are going to learn how to solve log equations, and then you can do that by hand, but for now we need to use our calculator. And then lastly, our vertical asymptote. So because our x is shifted, our vertical asymptote is now at x equals -2. And that concludes our notes today. Just a brief introduction into graphing logs, as they are just inverses to our exponential functions.